Okay, today we're looking at shapes of molecules, and there are several different shapes we need to learn, in fact 5 of them. So we'll start with the simplest and work our way up. So we're going to start with something that's just covalently bonded twice. And this is beryllium chloride. And the first thing you'd probably spot is that it's not got a full out shell on beryllium. This is one of the rare exceptions where it doesn't need to have 8 in its outer shell to be balanced. And we're going to look at 4 different things. We'll look at the number of bonded pairs, and this is around the central atom. The number of lone pairs, and again around the central atom. This will then be able to tell us its shape and also its bond angle. So if you look at beryllium here, that is our central atom. Nice one in the centre. The other things are bonded to it. So we've got here bonded pairs. Now this means how many covalent bonds has it's got? It's got 1 here and 1 here. So that has 2 bonded pairs. Next thing we look at are lone pairs around the central atom. And this beryllium has no lone pairs. There's no electrons there. A lone pair would look like that. 2 X's together. So this doesn't have those. So we're going to say it's got 0 lone pairs. So that means beryllium shape looks a bit like this. What happens is the electrons in these bonds push away from each other and they try and get as far away as possible. So in this, they try to get as far away as possible, and that is just to go from one side to the other. So that gives us this shape, which we just call linear. Nice straight line. The bond angle in a linear is 180 degrees. From this bond right round to this bond, we've got 180 degrees there. So that's the first one. And we've looked at the central atom, we've identified it's got 2 bonded pairs, so we put 2 there. We've identified it's got 0 lone pairs, so we put 0 there. Its shape then, because it's got 2 bonded pairs, no lone pairs, is going to be a linear shape with a bond angle of 180 degrees. So next up, we're going to do exactly the same thing. If you wanted to, you could pause the video and you try and work out how many bonded pairs, lone pairs, see if you remember shape and bond angle. But here, our bonded pairs, we have 1, 2, 3. Boron is our central atom because the fluorines are bonded to it. Boron has got no lone pairs. We can see some around the fluorines, but there's none around the boron. So we say 0 there because it's our central atom we're looking at. So the shape of this molecule, each one tries to push away as much as it can, so we get this triangle shape. This we call trigonal planar. They're all in the same plane, so you could lay this down flat. It's not a 3D shape, hence the planar, and it's like a triangle, so trigonal planar. The bond angle between each of these bonds, it's now smaller than it was in the linear shape we saw. It's down to 120 degrees. I should put that there. So that's our 3 bonds, no lone pairs. Next up, and again, if you wanted to, you could pause the video now and try and work out what we've got here. First of all, I've lost some marks there for not putting the carbons and the hydrogens in. Not always important, but because I've not done the inner shell on the carbon, I've got to identify that as carbon. So, we've got bonded pairs around the central atom. That's our carbon, because all the hydrogens are bonded to the carbon. We have 1 there, 2, 3, and 4. So 4 bonded pairs. Lone pairs around the carbon, we have 0. Now the shape of this, suddenly it goes into a 3D structure now. So before we saw them just forming nice lines and planar structures that you could lay flat. Now we're getting a 3D structure. To draw this, we have 1 hydrogen going straight up and 1 hydrogen coming down, and it's about there. say 6, 7, about 7:30. Then, to represent a hydrogen coming out towards us, so this isn't in the same plane as these two hydrogens, we draw a wedge with a hydrogen on, and to show one going away, again, to show it's going away from us, we draw a dotted line. So it's trying to represent a 3D structure there. This shape is tetrahedral. So if you joined all the sides up, you get a 4-sided shape. The bond angle is rather confusingly 109.5 degrees. So that's just one of the bond angles you're going to have to remember. And that is our tetrahedral shape, bond angle 109.5 degrees. So all these bonds are 109.5 degrees away from each other because they're all pushing equally away. So now we're going to have a look at ammonia. This is NH3. Pause the video if you want to give this a go yourself. So we'll start. We have 1, 2, 3 bonded pairs. And now this is the first time I'm going to see a lone pair on our central atom. Just here. 2 X's together. So that's 1 lone pair. So this has the total number of bonded pairs and lone pairs. It's the same as the tetrahedral structure we saw before. And the shape looks a bit like the tetrahedral structure. We have our N in the middle, and then at about 7:30 we have that hydrogen. We also have a hydrogen coming out towards us, just like in tetrahedral, and a hydrogen coming away. And there are 3 hydrogens. Now this lone pair, I'm just going to put 2 dots on. Sometimes you'll see a little loop around them. I'm just going to put 2 dots. But they don't really contribute to the shape. So this isn't tetrahedral anymore. What we've created is a little pyramid. This is known as pyramidal. If you want to be pedantic, it's trigonal pyramidal. Now the bond angle is very similar to what we saw in the tetrahedral shape. The lone pair of electrons is repelling the bonds just like each of the bonds are repelling each other. But the lone pair repels just a little bit more, and that changes the bond angle slightly. So it goes from 109.5 we saw earlier to now 107 degrees in NH3. Next up, and the final one we need to look at, good old water. So with water, you want to give it a go. Pause the video now, otherwise we can see it's got 2 bonded pairs straight away. These aren't bonded. These are our lone pairs, and water has 2 lone pairs around the central oxygen atom. This gives it a slightly different shape. So very similar to the very first one we saw, with a slight difference. We've got our oxygen in the centre, we've got 2 lone pairs of electrons, and they repel the 2 hydrogens as well. So you get this sort of bent structure, and that's one of the names we could give to this. We could call it bent or non-linear. Either one of those is fine. We saw earlier, when we looked at NH3, get that water back slightly, the bond angle got pushed down slightly by the lone pair of electrons. So the bond angle in this is also going to get pushed down by the lone pair of electrons. It's got a total number of 4, so it's very similar to tetrahedral, but it's got 2 lone pairs. If it had 1, it goes to 107. This has got 2, so it goes to 104.5 degrees. They are the 5 shapes, beginner shapes, that we need to learn. So, good practice with this, set this out, cover up what you have here, and see if you can remember what goes in, reveal it, check what your answers were to what the actual answers are, see if you're remembering what they are. Good luck.